In this video, we're going to talk about how to solve a system of equations using a matrix, which is a process that takes quite a bit of steps and quite a bit. So in this video, I'm going to try to mainly focus on how do we do it, how do we translate the system to a matrix, what are the step-by-step ways of doing it, and then actually kind of comparing to the process of elimination, which we talked about back in 3.4. So let's just get into all of the details. And first of all, the primary goal is to take a system and rewrite it as a matrix. Well, what we refer to as an augmented matrix, because as we saw in the last video, you can take a system like this and translate it into a matrix equation as such. And there actually is a way of using a matrix inverse to solve that. But that's getting a little bit more technical than we need to get for the purposes of our class. But basically, instead of doing it this way, we're going to take the matrix and write it in what we call its augmented form. So like an example of what I mean by this is, say, for example, I was taking a simpler system like this one, 2x minus y equal 5, and x plus 4y equals 7. The augmented matrix would be basically just a matrix where we've extracted all of the coefficients and the equals section, but left off the variables. So notice basically I'm taking the coefficient 2, minus 1, 5, 1, 4, 7, and putting that into matrix form instead. And we notice this is not an equation or anything, but it's referred to augmented matrix because it's not really the same thing. It's just a way that we write it to collect the most relevant points of information. Because otherwise it's assumed that, okay, we've got variables in the normal setup. And if we expand that to a more complex system of equations, say for example with 3 variables and 3 unknowns, that would translate into an equation where, we'd have each of these columns would be x, y, z of the coefficients on those, and then equal to the number on the right-hand side. So basically we're putting each of these equations into their standard forms, and then we translate it into matrix form as well. So say we wanted to solve this system of equations using matrix methods that we're going to talk about in this video. First step is we would need to write it as an augmented matrix. So let me move back to the whiteboard and we'll go ahead and do that. So it says find the augmented matrix of the following system. But notice that this system is a little bit awkward looking from its initial setup because it's not organized in a perfect way as before. But what I can see is, well, my first equation has the elements 6x minus 2y minus z equal to 4. And so basically I'm going to set up a matrix where, okay, I have 3 variables and I have equals. So that's going to result in 4 columns, 1 for each coefficient and then 1 for the answer column. Notice that in my second equation, though, that would be the second row of my matrix, I have x plus 3z equal 1, but there's obviously 1 missing. There's no y term. So well, I have 1x, but I have no y's, 3 z's, and equal to 1. So basically, I need to make sure that I fill in 0 in for each missing element of my equation. Since there is no y, well, really that's equivalent to plus 0y. And like in the third equation, I have no x's, which would be equivalent to 0x. So I would put a 0 in for the x column, 7 for the y column, 1 for the z column, and 5 for the answer column. But basically, just make sure any missing elements are filled in because I kind of want to imagine that each column has is correspondent to its own respective variable. And if I don't have one, like if I have no y's, that should be, I should have a 0 in that answer column. So in summary, this would be my augmented matrix for this particular system of equations. And all that means is this is going to be our starting point for solving a system using matrix methods.